What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 12, Review Exercises. Let's do it. For the following exercises, write the equation of the ellipse in standard form. Then identify the center, vertices, and foci. All right, so this one pretty much is in standard form, right? Standard form, the only difference is we'd want to have minus the coordinates of the vertex. Well, it's kind of there, but there's nothing in the minus, right? Or in the parentheses that should be there. So then we can assume that that's going to be 0. So I can rewrite it like this, boom, boom. And then I got y minus 0 over here as well, squared over 64, and that's equal to 1. So this helps me identify the center of the ellipse, which is going to be at 0, 0. Then if we want to know, here, let's write the center, little c there. And then if we want to find the vertices, okay, so these values are going to tell us where the vertices and co-vertices are. The co-vertices are going to be going horizontally because we can see that this is the smaller value. That's what we call the co-vertices. The vertices of the minor axis. So we take the square root of 25, which is 5, okay? And then we go left and right by 5 from the center. So we can say the co-vertices, we'll just call them vertices here because they call them vertices. They lump them all together in the back of the book. So it would be 5 to the left of 0, which is negative 5. We leave that y value the same. And then we got 5 to the right, which is positive 5, 0. Then going back to the center, we go up and down by the square root of 64, which is 8. So we've got 0, negative 8 going down, and 0, positive 8 going up. Last but not least, we need the foci, and the foci are going to be along the major axis. So once again, if we kind of have a rough sketch with 0, 0, right, this is going to look something like this, and the foci are going to be here and here along that major axis. So the way we figure that out is with our formula c squared equals a squared minus b squared. This is a squared, this is b squared. It's just the bigger one's going to be a squared. Okay, so it's 64 minus 25, and that is going to be 39. So c squared equals 39, square root, c equals square root of 39. So to get the foci now, we go back to the center, and we go plus or minus that value, okay? So we've got, and again, the major axis is going vertically, so we've got 0, positive rad 39 for one of the foci, the other one is 0, negative rad 39. Last but not least, if we do want this in the standard form as they have in the back of the book, I'm going to turn this back into b squared and a squared, which means that 25 is 5 squared, okay? And 64 is 8 squared. And that's how you do it. Done. So for this one, we're going to start by grouping the y's together and the x's together. So I'm going to reformat this like so, 9x squared plus 54x. And then I've got y squared minus 4y. And then we're going to bring that constant to the other side by minusing it. So we got negative 76 over here. Now what I'm going to do with the x's, I'm going to factor the 9 out. Okay, so then I've got 9 times x squared plus 6x. And in here, I'm going to complete the square. So I'm going to take half of this and square it. Half of 6 is 3, squared is 9. And that's going to be good to go there. And then over here, we're going to complete the square as well. We're going to say y squared minus 4y. We're going to take half of 4, which is 2. We're going to square that, which is plus 4, is still equal to negative 76. But notice, I've now added a 9 here, which is being multiplied by that 9. That's an 81. And to keep this balanced, I need to add 81 here as well. And since I added a 4 here, I need to do the same here as well. Okay, so now we've got two perfect squares here and here. So let's factor those. So now we got 9 times x plus 3 squared plus y minus 2 squared, this is just factoring, okay, is equal to negative 76 plus 81 is 5 plus 4 is 9. Last but not least, we're going to divide everything by 9, boom, boom, and boom, and we're going to end up with 9 over 9 is going to cancel out, so we got x plus 3 squared over 1. And again, I'm just going to write the 1 squared as they have it in the back of the book. So now we have that. And then over here, we've got over 9. But I'm going to change it to the square root of 9, which is 3 squared. Okay. And then 9 over 9 is equal to 1. And we need that 1 over here for standard form. All right. Now let's get all the values. And again, if I'm going to just roughly graph this, let's just take a rough graph so you can kind of get a general idea. I can see that my center is at negative 3, positive 2. Okay, so let's say we have negative 3, positive 2 right here. And then we've got going on the major axis 3 up and down. It's going to be longer than it is wider. So if this is at positive 2, it's going to be going down here and up here. And then it's only going to be going out to the right and left by 1. So now we got a rough graph of the ellipse. And now let's get all those vertices in place. So first, the center, which as I mentioned is -3, 2. Then I got the vertices. And again, starting from the center point, let's do all 4 of these. Starting from the center point, we're going to move these A and B values vertically or horizontally, depending on whether they're under X or Y. So let's do the co-vertices first under X. So that's going 1 to the left, 1 to the right of the center. So we'd have to the left would be -4, 2, to the right would be -2, 2, right, adding 1 to that. And then for the Y's, we're going to add and subtract 3 from that 2 value. So we got -3, 2 minus 3 is -1, -3, 2 plus 3 is 5, okay? Last but not least, to find the foci, we need to get our C value, and again, C squared equals A squared minus B squared, and whichever one is the A squared is the bigger one, right? So it's going to be 9 minus 1, right? 3 squared minus 1 squared, and that's going to give us 8 squared. So C squared is equal to 8. To take the square root of that, C is therefore, the square root of 8 is 2 rad 2 when you simplify it. So now let's write out the foci. And again, the foci are going to go along the major axis, along the Y. So we're going to keep the X value the same as the center, and we got -3, -3, but then we've got 2 plus 2 rad 2, 2 minus 2 rad 2, and that's it. That's how you do it. Done. So for this one, we're meant to graph the ellipse, and the good thing is it's pretty much in standard form. The only modification I'm going to make is I'm going to take the square root of 36, which is 6, and write it as 6 squared plus y squared over 3 squared is equal to 1. Now, since it's not x minus something or y minus something, I know that my center is going to be at the origin, which is going to be at 0, 0. So I'm going to start there, and then I can get my vertices, right? My vertices for the x is going to be 6 to the left and 6 to the right because of this value, right, from the center. So we're going to have one here at 6, 0. We're going to have one here at -6, 0. And then we're going to go up and down because that's under the y value of by 3. So we're going to go up 3. There's one of the co-vertices, and down 3. There's the other co-vertice. Now let's graph that. So there's the ellipse, and last but not least, let's get the foci. So the foci we're going to get by saying C squared is equal to A squared minus B squared, or 36 minus 9, and that is going to be 27. And we can take the square root of 27, and that is going to be 3 rad 3, right? Because you have 3 times 9, 9 is a perfect square, it comes out as a 3. And square root of 3 is approximately 1.7, let's say. So 3 times 1.7, this is about 5.1, 5.2, something like that. So if we're going to graph those foci now, we're going to say going out maybe like right here, and right here approximately, and with the coordinate being 0 for the y value, but then for the x value, it's going to be 0 plus or minus 3 rad 3. So over here, it's the positive 3 rad 3. Over here, it's the negative 3 rad 3, 0. And that's how you do it. Done. So for this one, before we can graph it, we want to get it into that nice standard form. And the way we're going to start is we're going to group the x's and the y's together. And actually, let me shrink this down because we're going to need a little bit more room here. So we've got 4x squared plus 16x, and then we've got plus y squared plus 4y. And then we're going to add that 44 to the other side equals 44. Now we want to complete the square. So before we do that, we have to factor out that leading coefficient of 4 here. So I'm going to say 4, and then we got x squared plus 4x, right? Divide both of those by 4. Let's leave those in parentheses. This is fine as is. Y squared plus 4y. Notice I'm having to break this up a little bit by lines, but it's all good. It'll still look good. And then last but not least is going to be equal to 44. So now what we're going to do is we're going to complete the square. And up here, we're going to do that by taking half of this and squaring it. Half of 4 is 2 squared is 4. So we're going to add 4, but we're also going to add that to the other side, remembering that that's not just a 4, that's a 4 times 4. So we got to add 16 over here. And then over here, we're going to complete the square again. Half of 4 is 2 squared is 4. So we're going to add 4 and 4 like so. Now we get a nice final equation of 4 times x squared plus 4x plus 4 can be factored into x plus 2 squared. Over here we've got y plus 2 squared, when we factor that, is equal to 60 plus 4 is 64, okay? And finally, we're going to get a 1 here, so we want to divide everything by 64, like so. 4 and 64 cancels out to 1 and 16. So my final equation in my nice standard form is going to be, let's see if we can squeeze it in here. We got x plus 2 squared over 16, which I'm going to write as 4 squared, okay? And then we've got plus y plus 2 squared over 64, which is 8 squared, and that's equal to 64 over 64, which is 1. All right, this is excellent. Now I know my center is going to be at -2, -2, right? So we've got -2, -2 right here. Here's my center. And then on the major axis, the bigger one, we're going up and down by 8. So down by 8 is -10. So there is one of my vertices. So we've got -2, -10. And then also we're going to go up 8, which is going to be -2, 6. We're going to go left by 4. Left and right by 4. So left by 4 is right here. That's going to be -6, -2. Right by 4 is going to be 2, -2. So let's go ahead and draw that in. And last but not least, we need to get the foci. So to get the foci, we're going to use our equation c squared is equal to a squared minus b squared, the bigger one minus the smaller one. That's 64 minus 16, which is 48. So c squared equals 48, which means c equals the square root of 48. Since 48 is 16 times 3, it simplifies to the square root of 16, which is 4 radical 3. And then the foci are going to be up that amount and down that amount from the center. So the square root of 3 is approximately 1.7-ish. So 4 times 1.7 is about 6.8, maybe like 7. So let's say we're going to go about 7 above, so maybe like somewhere right there, and 7 below, so maybe somewhere right here approximately. And we're going to give those two coordinates as -2. And notice I'm going along the major axis, right? -2, -2 plus 4 rad 3. And then over here, it's going to be -2, -2 minus 4 rad 3. And that's how you do it. Done. So for this one, we're trying to find the equation for the ellipse, and the center is going to be really important because we know that at the beginning, it's going to be x minus that value for the center, x minus 0 squared. And then we know we're going to have y minus 0, the y value of the center, right? So really, we could write it as y squared and x squared, but I'm going to put it like this just as a reminder. Over here, we know we're going to have a 1. Now, since we have a vertex at -5 and a focus at 3, we can kind of get a slightly better idea of what this is going to look like, right? Centered at 0, 0, vertex at -5 right there. That means we also have another vertex at +5. So what does that mean? It means that this axis is 5. So that's the value that goes under the x value, 5, and we're squaring it, right? So we could write 25, but we're going to write 5 squared. By the way, we're going to have a plus in between here. Now, I know that this is the major axis because the focus is also on the x-axis as well as right here, and it would also be one at -3. But the important part about that is it means that my c value is the distance from the centers of the focus. So my c value is going to be 3, and that's going to help us find this value. So since I know that this is the larger value, I can create my equation c squared equals a squared minus b squared. Again, a squared is the larger one. So c squared is 3 squared, which is 9, equals 25 minus whatever b squared is, okay? So then we're going to subtract 25 from both sides. 9 minus 25 is -16, equals -b squared. Cancel out the negatives, and the square root of b, therefore, is 4. So what's going to go under here, therefore, is going to be 4 squared. And that's how you get the standard equation. They might have x as opposed to x minus 0, but as I said, I'm going to leave it there because you can clearly see the center at 0, 0. That's how you do it. Done. A whispering gallery is to be constructed such that the foci are located 35 feet from the center. If the length of the gallery is to be 100 feet, what should the height of the ceiling be? So we're going to do a rough graph, and we're going to say that here's my center. We're just going to assume it's at 0, 0, and we're just going to get an approximate graph just to understand what's going on. So the foci are 35 feet from the center. Let's say here's one foci at 35. Here's another foci at -35, again, assuming this is going to be an ellipse. Now it says the gallery has a length of 100, which would mean that I would go 50 out this way and -50 out this way, right? And that's going to be our major vertices, our major axis. And I know that because this foci is going to be on that major axis, right? It's got to be the same. So there's my length. And then it says, what's the height? So what are these values in terms of an ellipse, right? Well, this is going to be my C value, right? That's the distance from the center to the focus. This is going to be my A value. Again, A and B are kind of arbitrary, but since A is going to be the bigger one on the major axis, we'll call this A. And what am I solving for? The height, aka B. So now we know what we need to find, and we have the information necessary to use our C squared is equal to A squared minus B squared formula, where C is 35, so it's 35 squared, is equal to A, which is 50 squared, minus B squared. And again, we're solving for B, not B squared. So we're going to minus 50 squared from both sides, right? Minus 50 squared equals negative B squared. Then we're going to multiply everything by -1 to get rid of that negative. And then since I want B, not B squared, I need to take the square root of both sides. So let's do that in Desmos now to find B. So we got square root of 50 squared minus 35 squared. And when we get that result, we get 35.7 or 35.71 rounded to the nearest hundredth. So the height would be 35.71 feet approximately. That's how you do it. Done. So for this one, we're doing a hyperbola in standard form. Notice the real only difference is that we got a minus instead of a plus compared to an ellipse. But this is pretty much in standard form. All we're going to do is we're going to replace that 16 as the square root of that squared, 4 squared. And then this one is going to be 6 squared, right? 36 squared of that is 6. And then we're pretty much good to go here because we can already see that the center is going to be the opposite of this, comma, the opposite of this, aka 4, comma, -1. And since we have the y value in front, we know that if we imagine this as 4, -1 right here, it's going to be going up and down. So that means the vertices are going to be this value above the center and below it. So we're going to have vertices at 4, comma, -1 plus 4 is 3, and 4, comma, -1 minus 4 is -5. And last but not least, to get the foci, we got to use our equation C squared equals A squared plus B squared. Again, slightly different from the ellipse. It's a plus instead of a minus. And these are kind of arbitrary, but we'll say that's A squared because that's before the minus sign. So C squared equals 4 squared, which is 16, plus 6 squared, which is 36. Sorry, that was meant to be an equal sign. 16 plus 36 is 52 equals C squared. And the square root of that is square root of 52, which is 4 times 13. Square root of 4 is 2. So we get 2 rad 13. So now to get the foci, again, the foci are going to be up here and down here. So it's kind of like how we got the vertices. We keep that x value the same. And then from the center value at -1, we're either doing -1 plus 2 rad 13 or -1 minus 2 rad 13. And that's how you do it. Done. So for this one, we got to get it into standard form, and that's going to first require us to group the x's together. So we got 3x squared minus 12x, and then we've got minus y squared minus 6y, and then we're going to add 9 to the other side. And now we got some factoring that we want to do, right? For this front one, I'm going to factor the 3 out, and we're going to be left with x squared minus 12 divided by 3 is 4. Give me 1 second. We're just going to replace that. And then we have to complete the square here. For this one, I'm going to factor out the negative. That's going to make that positive, okay? And now we're going to complete the square. So I'm going to take half of this and square it. Half of 4 is 2, squared is 4. Half of 6 is 3, squared is 9. And then we're going to add the same to the other side, right? We can't just add things to the left side without adding them to the right side. But remember, I'm doing really 3 times 4, which is a 12, so I got to add 12 here. And then we've got a -9, so I got to add a -9 here. Now we can factor this and this. Those are nice perfect squares. So we're going to have 3 times x minus 2 squared minus, and we're just going to have 1, so just going to be y plus 3 squared, okay? And this is all equal to 9 plus -9 plus 12 is 12. But we don't want a 12 here, right? So we're going to divide everything by 12 to get a nice 1 there. 12 here and 12 here. And the 3 and the 12 are going to cancel out to a 4 on the denominator. So finally, we have x minus 2 squared over 4, which is 2 squared minus y plus 3 squared over the square root of 12, which is 2 rad 3 squared, again, keeping that in that nice standard format, is equal to 1. Okay, now we can figure everything out. And again, I'll just do an approximate graph, but just remember, since the x is first, this is going to be going left and right. So if we have it here, and our center, okay, the center is going to be 2, -3. So we got a center at 2, -3. Again, just making an approximate graph. Here's 2, here's -3, boom. It's going to open boom and boom. That's what's going to be the hyperbola. All right, so now we want to get the vertices, and the vertices are going to be this value right here to the left and right of that center. So my vertices are going to be 2 plus 2, which is 4, comma -3, and 2 minus 2, which is 0, comma -3. Now to get the foci, we need to get our c value using the equation c squared is equal to a squared, which is 4, plus b squared, which is 12. And 12 plus 4 is 16, so c squared equals 16. Taking the square root, we get c is equal to 4. So now my foci are going to be, again, adding to the x value of the center, just like the vertices. So we got 2 plus 4, which is 6, comma -3. 2 minus 4, which is -2, comma -3. That's how you do it. Done. So for this one, we're meant to graph the hyperbola, and we're going to start by identifying the center, which is the opposite of this, comma, the opposite of that, right? The xy. So it's going to be -1, comma 1. And since y is first, we know this is going to go up and down like so. So here's our center at -1, 1. Then I want to identify the vertices, right? And they're going to be, since it's going up and down, it's going to be up from the center by the square root of this and down from it as well. So the square root of 49 is 7. So we're going to have vertices at -1, comma 8, right? 1 plus 7. And -1, comma -6, right? 1 minus 7. Now to get the foci, okay, we're going to use our equation c squared equals a squared plus b squared, and that's this value plus this value. And that's going to be 49 plus 4, which is 53. So c equals the square root of 53, which is approximately 7.28, right? So we're going to have a foci at -1, 8.28, again approximately, and another foci at -1, -6.28, right? Because that's going to be 1 minus 7.28. Now, they didn't ask for the asymptotes in the back of the book, but I'm going to just show you what the asymptotes look like because it makes the graphing a lot easier. And the easiest way to do it, if you don't want to write out the equation of the asymptotes, you can say, all right, well, both the asymptotes go through this center, and the slope is going to be +7 over 4, okay, or over 2, excuse me. Where did I get those values? Square root of this over the square root of that, and that makes sense. Rise over run, right? The rise is under the y, the run is under the x. So it's going to be +7/2 and -7/2. So we can do a quick drawing here for those asymptotes. So that means it's going up 7 and then to the right by 2, and then also -7/2, so up 7 to the left by 2, and then the graph kind of goes within those asymptotes. So it just gives you a little boundary that you can make this sketch a little bit more accurate. That's how you do it. Done. So for this one, before we can graph it, we got to get it into standard form, and I'm going to do that with a little factoring by grouping. So we got 2y squared minus 12y. We're going to bring those together. Then we've got -x squared. There's no other x term, so that's just chilling. And then we're going to add the 6 to the other side. So this is all equal to 6, okay? So I know it's spaced out kind of funny, but I like to do it that way so we can kind of have separation between the terms. Now, for this one, I'm going to factor out that 2. So we got 2y squared minus 6y. We're going to leave a little bit of room. For this one, I'm going to factor out the negative. So we got -x squared. And over here, we're going to have 6. Now, I don't need to complete the square for the x because it's already a perfect square. But for this one, I do need to, and I'm going to do that by taking half of that and squaring it, which is 9. But remember, that's really an 18, and if I add an 18 to the left side, I must add 1 to the right side. So now we can simplify this a little bit further, and I've got 2 times, that becomes a nice perfect square of y minus 3 squared, if you factor it. And then we've got minus x squared, or we could say x minus 0 squared, just to let you know that the center is going to have a 0 value for the x coordinate is equal to 24. Last but not least, let's divide everything by 24. So we got 1 on that side. And if we go 24, 24, 24, we're left with y minus 3 squared over 12, but I'm going to say the square root of 12 squared, or 2 rad 3 squared. Again, the square root of 12 is 2 rad 3. minus, and then we'll just say x squared. Just remember it is the same as x minus 0 squared over 24, which I'm going to say the square root of 24 squared, which is 2 rad 6 squared is equal to 1. So this means that we have a center at 0, 3, right? Because of that right there. And we also know since the y value is first right here, this is going up and down like so. So there's my center. Now to get the vertices, we're going to go up and down by this amount. So we're going to keep that. So there's the center value. We're going to keep that x value for both of these, right? It's just going vertically. And what we're doing is we're going to be adding 2 rad 3 and subtracting 2 rad 3. So 2 rad 3 is about 3.5, okay? So up 3.5, maybe right there, and down 3.5, maybe right there. So those are the vertices. And the approximate value is 0, negative 0.46. If you run it through Desmos and calculate 2 rad 3 and approximate to the 100th. And then up here, we've got 0, 6.46 approximately. And now to get the foci, we need c squared is equal to a squared plus b squared. And again, this one squared here is going to be 12. This one squared here is going to be 24. So c squared equals 36, which means c equals the square root of 36, which is 6. Okay, so what does that mean? That means I'm going up and down by 6 from the center. So if there's my center, here's one of my foci, it's 0, 9. Here's my other foci, down by 6 at 0, negative 3. And again, I know that they didn't give the asymptotes in the back of the book, but we're going to do it once again with that rise over run. And now I'm going to have to approximate because it's 2 rad 3 over 2 rad 6. That's the slope. So it's rad 3 over rad 6. So it's approximately a slope of 0.7. So 0.7 up and 1 over. So that's one example, again, going through that center. And there's the other way, just that same slope, but negative. So just to give an approximation. And then now we follow out, we kind of hug those asymptotes and see how it just helps us, it guides us to give us a more accurate graph. So I highly recommend it depending on the level of accuracy you want. So anyways, that's how you do it. Done. So for this one, we're meant to find the equation of the hyperbola. And I just put up this graph here just so we can get a rough idea of what the graph looks like. So we've got a vertex at 6, 7 right here. And it also says we have foci at 3, 7, and 7, 7 right there. All right, so what this is going to imply is, again, the vertices are going to be inside the foci, right, for a hyperbola, and they're going to be equidistant from each foci. So this is a distance of 1. This should be a distance of 1 as well. So my other vertex is right here. So now we have my two vertexes at, one is at 6, 7, vertices, I should say, and the other one is at 4, 7. So why does that matter? Because the center is right in the middle, which is going to be at 5, 7. And that's what's important for the formula. And by the way, since the foci are here and here, we know that the hyperbola is going to open around those. So again, just to get a rough idea, it's opening left and right. Now, when it's opening left and right, I know that the x is going to come before the y. And this is, again, all going to equal 1. So we've got the x here, and we've got the y here, remembering that both of these are squared. And now we minus the coordinates for the center value. So it's x minus 5 and y minus 7. All right, now we got to get the values underneath here, right? So if I look at the distance to the vertex or each of the vertices, it's 1, right? So under here, we're going to have that distance 1, and we're going to square it, but that's, of course, just going to be 1. But then what about the value that goes under y? So that's the interesting bit. We're going to use this value, this distance to the foci, or focus here, this focus, which is 2, and that's our c value. And we're going to remember our equation is c squared equals a squared plus b squared for a hyperbola. And c squared, again, is, or c is 2, so 2 squared is 4. That c squared is equal to a squared, which is 1 squared, which is 1, plus b squared. And now we're going to subtract 1 from both sides. 3 equals b squared. And of course, b then equals the square root of 3. But again, under here, we're going to put rad 3 squared, which is just 3. And even in the back of the book, they just changed this 1 squared to 1. So we'll leave it the same way. And that's how you do it. Done. So for this parabola, we're meant to put it in standard form, but it's already in standard form, okay? And because we got an x squared here, right, we know it's going up like this, okay? And we also know that we have a nice vertex at the opposite of this negative 2, comma, the opposite of that, which is 1. Now, when we're in this format, right, this constant up here, 1/2, is actually equal to 4p. And so to solve for a p value, I'm going to divide by 4, and p is equal to 1/8. So now, once again, we've got negative 2, comma, 1 right here for the vertex. And because it's 1/8, and because this is a positive value, right, we know that the focus is going to be 1/8 above this. Let's say like roughly right there. And then the directrix is going to be 1/8 below it. So I know this is really tight quarters. It's going to be down here. So what is my actual directrix line? It's going to be y is equal to 1/8 below 1, which is 7/8. And then my focus up here is going to be negative 2, 1/8 above 1, which is 9/8. That's the focus. And then just to give you a rough idea of the graph, it's going to kind of go around like this. I don't know if this is very to scale, but that gives you the general idea. Anyways, that's how you do it. Done. For this one, to get it into standard form, what we're going to have to do is we're going to have to complete the square. And I'm also going to add y to the other side. So I've got y, and then I'm going to minus 23 as well. So y minus 23 is equal to x squared plus 10x. Now to complete the square, I take half of this and square it. So half of 10 is 5, squared is 25, but we're going to add it here as well, right? And then we're going to factor this guy, right? Because it's a perfect square. So that's going to be x plus 5 squared is equal to y plus 2. Now, since there is no value out here, I'm just going to put a little 1 in. Since it's x squared, we know that this is going up, again, because this is positive. So now let's figure out the vertex. The vertex is going to be the opposite of that, negative 5. The opposite of that, negative 2. So that's going to be negative 5, negative 2, like so. Now to find the directrix, we need the p-value. So again, this 1 right here is equal to 4p, which means p is equal to 1 divided by 4, right? Isolating by dividing by 4. So if p is 1/4, and once again, we're going to go vertical, we're going to go up. So I know that the directrix is 1/4 below this. So let's draw that down here. And I know that the focus is 1/4 above it right here. So if my vertex is negative 5, negative 2, my focus is going to be negative 5, and then I'm going to add 1/4 to negative 2, which is going to give us negative 7/4, like this. And again, the directrix right here is going to be y equals negative 9/4, right? It's negative 2 minus 1/4. And just so you can get a rough idea of what the graph looks like, it's going to bend around the focus, and you're going to see it like that. Approximately, that's how you do it. Done. So for this one, we're going to graph the parabola. First, we're going to figure out what the vertex is, and I see it right here. It's the opposite of that, which is negative 3, the opposite of that, which is 1, and it's already in standard form, so that's pretty nice. And so we got negative 3, comma 1, so there's my vertex. And then we see that it's the y value squared. So when the y value is squared and this is positive, it means it's opening to the right. So it's going to roughly look like that. Now, to figure out where the directrix and the focus is, I need to set this equal to 4p. Okay, so in this format, 4p is equal to 1/2. If I divide both sides by 4, I've got p is equal to 1/8. Okay, and that's really cool because, again, as I mentioned, since we're going this way and this way, like this, to get my focus, I'm going to add 1/8 to that x value. So negative 3 plus 1/8 is negative 2 7/8, or negative 23/8 as an improper fraction. And then we keep that y value the same of 1. And then to get the directrix, it's going to be a vertical line, and it's going to be 1/8 to the left of this point. So it's x equals negative 25/8, right? Which is negative 3 minus 1/8. So now we can draw that out approximately here. And we got our focus approximately there, right? Something like that, just an approximation. And then we'd graph it this way. And that's how you do it. Done. So for this one, we're going to keep the 2y squared and the 12y on the left-hand side like so. And then we're going to set this equal to negative 6x minus 15, right? Subtracting both of those. Then I'm going to divide everything by 2. So I've got y squared plus 6y is equal to negative 3x minus 15 over 2, okay? Then I'm going to complete the square. So we're going to complete the square by adding half of this squared, which is 3 squared, which is 9, but we got to add it to both sides. And then now we've got a nice perfect square on the left-hand side. So it's y plus 3 squared is equal to negative 3x, and then negative 15 over 2, 9 can be rewritten as 18 over 2. So 18 over 2 plus negative 15 over 2 is positive 3 over 2. Last but not least, to get this into our nice format, y plus 3 squared, and then I'm going to factor out the negative 3. So I got negative 3 times x minus 1/2, because negative 3 times negative 1/2 is positive 3/2. Okay, there we go. So now we're in good shape. Now I can give you that the vertex is the opposite of this, comma the opposite of this, which is 1/2, comma 3, negative, of course. So then as we start to graph this vertex, we've got 1/2, negative 3 right here. Now, again, the y squared is here, and this is negative. That means it's going to open to the right. But to figure out where the directrix is and as well the focus, we need to get the p-value. So again, this value right here, 3, I'll just say 3, it doesn't matter. The fact that it's negative means that the focus is going to come here and the directrix is going to be here. But if we just remember that, the negative doesn't matter. So we got 3 is equal to 4p. We're going to divide both sides by 4, and p is equal to 3/4. All right. So now that means my focus is 3/4 to the left, meaning 1/2 minus 3/4, which is negative 1/4. Then we leave that y value the same. And then for the directrix, and now to get the directrix, we're going to add 3/4 to 1/2. So 3/4 plus 1/2 is going to be 5/4. So x equals 5/4. So 5/4 is 1 1/4. So we're going to do that directrix right here. And then our focus is going to be right here where you've got negative 1/4, negative 3. And then we're going to bend around it like this, bend around it like that. That gives you the approximate graph. That's how you do it. Done. So for this one, we got a focus here and we got a directrix here. So we're going to have a horizontal directrix at y equals 7/8, right? And then the focus is at 2, 9/8. Which let's say 1, 2 right here. It's going to be a tiny bit above. So I know that my vertex is right in the middle of those two. Okay, so what's the average of 9/8 and 7/8? You can kind of do that mentally. 9/8 plus 7/8 is 16/8, which is 2 divided by 2 is 1. So I know that my vertex is at 2, 1. And also, since I know that the distance up and down is 1/8, I know that my p-value is 1/8. Okay, now we can start to piece this together. So since this is going up, I know it's going to be x minus 2, the x value of the vertex squared, is equal to 4p. 4 times 1/8 is 1/2 times, and then in here we're going to have y minus the 1, which is that value of the vertex. And that's how you do it. Done. So for this one, we're meant to determine the type of conic section, remembering that this is A, B, and C. And what we're going to do is we're going to use b squared minus 4ac, and that's going to kind of tell us what this is. So b squared is 24 squared minus 4 times a times c, which is 9. So when we multiply this out, we get 0. And so when this quantity equals 0, we know that this graph is therefore a parabola. And that is how you do it. Done. So to determine the type of conic section, we got to remember that that's A, this is B, and this is C. And I'm talking about the coefficients, of course. And we're going to see what is B squared minus 4AC, right? When it's 0, it's a parabola. If it's less than 0, it's an ellipse. So let's check it out here. So B squared, that's a 1 in front of the XY term. So that's 1 squared minus 4 times A, which is 4, times C, which is 2. So 1 squared is 1 minus 4 times 2 is 32. So that's equal to negative 31. So since this is negative, this is going to be an ellipse. That's how you do it. Done. So for this one, before we start, to find the angle, we have to recognize that this is A, B, and C, and meaning those coefficients. And to find the angle, first we're going to use the equation cotangent of 2 theta equals A minus C over B, which in this case is 1 minus 1 over negative 1, right? That's my B term. So 1 minus 1 is 0, so this is equal to 0. So cotangent of 2 theta is equal to 0. So to solve for theta, we're going to take arc cotangent of the other side. So arc cotangent of 0. And then to get theta, we're going to divide by 2 like so. So there we go. In degrees, that gives us 45 degrees. So my theta value is going to equal 45. All right. So now as we start to make the transition to have no xy term, we have to remember these two equations up top. And since theta is 45, we can write it out as follows. So my x is now going to equal x with that little dash, and then cosine of 45 is going to be rad 2 over 2, and so is sine of 45. So they're both going to be the same. So then minus y rad 2 over 2. So this is my new x. And then my new y is going to be x prime rad 2 over 2 plus y prime rad 2 over 2. Now we're going to sub these in for the x and y's up here. So we're going to have a little bit of work to do here. But first we have x squared, so that's going to be rad 2 over 2x minus rad 2 over 2y, and this value is going to be squared, minus x times y, which is rad 2 over 2x minus rad 2 over 2y, and then times the y, which is rad 2 over 2x plus rad 2 over 2y. And you're going to see that's going to work out nicely. It's a difference of squares. And then plus my y squared, which is rad 2 over 2x plus rad 2 over 2y right here, right? That y squared, and then minus 6 is equal to 0. Now we're going to do a little foiling of this binomial. So this binomial times itself, we're going to get rad 2 over 2 times itself, which is 2 over 4, or 1/2 x squared. I'll put the dashes back on at the end. And we got x squared, and then it's this times this doubled. So rad 2 over 2 times itself is again 2 over 4, or 1/2. Times itself, or doubled, sorry, is just 1. And then that's going to be negative 1xy, and then plus this value squared right here, right? I'm just doing the foiling kind of mentally. And then it's again going to be 1/2 plus 1/2 y squared. And then over here we're minusing, and then it's this kind of like difference of squares. So it's really just these two and these two multiplied, because the inner terms are going to cancel out. So that's going to be 2 over 4, or 1/2 x squared minus 1/2 y squared, right? And then we've got plus, and then this one foiled out. It's kind of like this one foiled out, except there's going to be a plus in between. So we've got 1/2 x squared plus xy plus 1/2 y squared. And obviously, if we're having a plus, we don't need parentheses. And then minus 6 is equal to 0. And by the way, I can distribute this negative, so that's going to make this positive. That one's going to stay negative. And now we're going to combine like terms. So the first thing I want to look at is, do the xy terms cancel out? Because if they don't, then we made a mistake. But I got negative xy, positive xy, boom, they go away. That's beautiful. All right, then we got 1/2 x squared, 1/2 x squared. That's just a single x squared. 1/2 y squared, 1/2 y squared, and then another 1/2 positive y squared. That's plus 3/2 y squared. Then I've got 1/2 x squared minus 1/2 x squared plus 1/2 x squared. That's a single 1/2 x squared. Then I got 1/2 y squared plus 1/2 y squared plus 1/2 y squared, which is 3/2 y squared, and then minus 6 equals 0. So now the last thing that they're going to do in the back of the book is they don't want these fractions, so we're going to multiply everything by 2, which is those denominators, and we're going to end up with x squared plus 3y squared minus 12 is equal to 0. So then we're going to end up with x squared, now I'll put those dashes back in, plus 3y squared minus 12 is equal to 0. Again, remembering that theta was 45 degrees. That's how you do it. Done. So for this one, once again, we got to remove that xy term, and then we're going to graph this equation. So we're going to start by finding the angle of rotation by saying cotangent of 2 theta is equal to a minus c over b, where this is my a coefficient, my b coefficient, and my c coefficient, right? And then, so we've got 1 minus 1 over negative 1. Now, of course, that's going to be 0. So if cotangent of 2 theta is equal to 0, we're going to take arc cotangent of that 0 to get rid of it. And then we got 2 theta is equal to that. We're going to divide by 2. And we're going to see what that is in Desmos. And we got 45 degrees. So now I know my theta value is 45. And now we're going to use our 2 equations. And we're going to plug in our 45 into both of those thetas. Again, there's going to be a dash here and all that. But I'm just going to leave it like this. Can be easier to write out. So now my new x, since cosine and sine of 45 is square root 2 over 2, we've got rad 2 over 2 times x minus rad 2 over 2 times y. That's going to be my new x. And then for y, we've got rad 2 over 2x plus rad 2 over 2y. All right, now we're going to plug those into the x's and the y's up here. So we've got rad 2 over 2x minus rad 2 over 2y, and this is squared, just like that x is squared up here, minus these two multiplied against each other because that's our xy, right? And then we've got plus y squared, which is this, so rad 2 over 2x plus rad 2 over 2y squared, and last but not least, minus 2 is equal to 0. So now as we FOIL out this binomial, it's going to be rad 2 over 2x times itself is 1/2 x squared. Then it's these guys multiplying against each other and doubling that. That's how you'd FOIL it out, right? Those are going to be the middle terms. So that's going to be negative 1/2 xy times 2 is just negative 1xy. And then plus this times itself, which is again 1/2 y squared. Now these we're going to get almost like a difference of squares situation. So we really only have to write down the product of these and the product of these. And I'm going to say minus in parentheses. That's going to be 1/2 x squared minus 1/2 y squared. And then we've got plus, and then this one FOILed out is going to be just like this, just everything is positive since there's a plus there. So it's 1/2 x squared plus xy plus 1/2 y squared, and then minus 2 is equal to 0. I'm going to distribute that negative. So this will be negative, this will be positive, and now let's combine some like terms. So of course, we want to make sure the xy's cancel out. That was the point of this, and they do, boom, boom. And then we've got for the x squared is 1/2 plus 1/2 minus 1/2. That's going to be 1/2 x squared. And then for the y squared is 1/2 plus 1/2 plus 1/2. That's 3/2 y squared. Minus 2 is equal to 0. Last but not least, let's multiply everything by 2. So then we're going to get x squared plus 3y squared minus 4 is equal to 0. Now let's graph that in Desmos. So here we go. There's our ellipse with vertices here and here, co-vertices up there and there. But that's how you do it. Done. So for this one, we want to start by getting it into standard form where this value is 1. But since that's already the case, we're kind of good to go. And just recognize that this right here is my eccentricity or E value. So E is going to be 5. And E times P on the top is 10. And since 5 is E, I can figure out my P value, right? Because what times 5 is 10? P is equal to 2. Now, since E is greater than 1, this makes this a hyperbola. And since we got P is equal to 2, and there's a minus sign, and it's cosine, we know that the directrix, therefore, is 2 units to the left of the pole. And that's how you do it. Done. For this one, we got to start by getting it into standard form, and that will be by turning that into a 1. So I'm going to multiply the top and bottom by 1/4. And then I get 1/4 over 1 plus 1/4 times 3 is 3/4 sine of theta, and this is equal to r. All right, so now I know this is my E value. So E is 3/4, and up top is E times P, right? So E times P is 1/4. If I know that E is 3/4, what times 3/4 is 1/4? Well, I can figure that out by multiplying by the reciprocal here of 4/3. Cancel, cancel. P is 1/3. So since this is a plus and this is sine, the directrix is going to be 1/3 above the pole. And also, since we have an eccentricity less than 1, this is going to be an ellipse. That's how you do it. Done. So this one, we want to make sure it's in standard form, but since we have a 1 here, we know that it is. And since there's nothing visible in front of that sign, we know that there's actually an invisible 1, and E is actually 1. And since the numerator is E times P, P therefore must be 3. So when we have a 1 for the eccentricity, that means that this is a parabola. And now we can start to graph this out, noting that our focus is going to be right here at the origin. And since I know that P is equal to 3, this is sine, and that's a minus. I know that the directrix is going to be 3 below the origin. So there's my directrix at y is equal to -3. Now the vertex of this parabola is going to be right in between the foci and the directrix at 0, -3/2. And now just for fun, we can get a couple of good values by plugging and chugging with theta and finding the corresponding r values. So I'm going to plug in 0, pi-halves, pi, and 3 pi-halves. These are easy to plug in and evaluate. Sine of 0 is 0. 3 over 1 minus 0 is 3. Sine of pi-halves is 1. That would be undefined because it's 3 over 0, so we'll just say not available. Sine of pi is 0 again, so it's 3 over 1. which is 3. And then sine of 3 pi halves is -1. 1 minus -1 is 2, so that's 3 over 2, which happens to be the vertex, right? Because if I go on the 3 pi halves axis and go down 3 halves, I'm right there. So let's plot these other 2 points. 0 is coming out this way at 3. Pi is going this way, and there's 3, which really is 0, -3. That gives us enough to make a nice graph. And that's how you do it. Done. So for this one, we're going to start by getting it into standard form by converting that to a 1 by multiplying top and bottom by 1/4. And then we've got 10/4 or 5 halves on the numerator over 1 plus 5/4 times cosine of theta. So my E value is right here. E is 5/4. And since E is greater than 1, we've got a hyperbola, and since the numerator is E times P, right, and that's equal to 5 halves, what times 5/4 is 5 halves? Well, that's going to be 2, right, doubling that. So P is equal to 2. And since we got cosine here, we know we're opening left and right. One of the foci is, again, going to be at the origin, and now we're going to make a little table here with theta and r corresponding values, again, doing 0, pi halves, pi, and 3 pi halves, like so. So plugging back into the original, it's going to be easy to evaluate this. Cosine of 0 is 1. 4 plus 5 times 1 is 9, so we got 10/9 here. For pi halves, cosine of pi halves is 0, so that's 10 over 4 or 5 over 2. Then we've got cosine of pi, that's -1. 4 plus 5 times -1 is -1. 10 over -1 is -10. And last but not least, we got 3 pi halves. Cosine of 3 pi halves is, again, 0, so that's 10 over 4 or 5 over 2. Okay, let's see if we can plot some of these points. So 0 coming out this way is going to be 10/9. That's just over 1, so we're going to say approximately right there. Then we've got pi halves going straight up, and that's 5 over 2 or 2.5 right there. Then we've got pi going this way, but then that's -10, so we're actually going the other way, so right here at 10. And then we've got 3 pi halves going down, and that's 5 halves or 2.5. So we got it like here. So I can start to see that this is going to bend around this focus like this pretty nicely. And then where's my other focus, right? Well, this one is 10/9 away to the left of that vertex. So this one is also going to be 10/9 in that direction. So since this vertex is right here at 10, 0, I'm going to add 10/9 to that. So again, 10, if I put it over a denominator of 9, would be 90 over 9 plus 10/9 gives me 100 over 9. So let's draw, and it's going to be a little bit off the grid here, but here's the focus, and this one is going to be 100 over 9, 0. Of course, the other one is at the origin. And we're kind of going off the grid, but you get what I'm saying, right? It's going to bend around that other focus, bend around it like that. And just for fun, we're going to also make sure to label this one. Again, as I mentioned, that's 10 over 9, 0. But anyways, that's the full graph with the vertices and the foci. That's how you do it. Done. For the following exercises, given information about the graph of a conic with focus at the origin, find the equation in polar form. All right, so we got a directrix at x equals 3 and eccentricity of E is equal to 1. So with eccentricity of 1, we know that this has to be a parabola. And if we know that we've got a directrix at x equals 3, we know that our p value is going to be 3 as well. All right, so now we can kind of piece this together. And by the way, with a directrix like this and a focus right here, we know that this is going to be going in this direction and this direction. All right, now let's plot it out. So we got r is equal to E times p, 1 times 3, which is 3, over 1 plus, and since it's opening left, it's going to be 1 cosine of theta. And just so we match the back of the book, if we have a 1 here, we don't really need it, right? So that is how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.